It began as a file that did not have a name on the cover. It was thin, but inside were lists that mattered. Places, factories, laboratories, aircraft sheds, mines, and office basements were written in small, tight type. A handful of officers and civilians circled targets with a pencil. They knew that the war in Europe would turn on fuel, guns, and food, but they also knew something else. Every design on a drafting table, every test bench log, and every crate of drawings waiting in a railcar was a second front. In the winter of 1944, while snow blinded the Ardennes and V weapons fell on cities, the United States built a quiet hunt inside the bigger war. A small network of technical intelligence teams would move with the field armies, slip in right behind the spearheads, and seize the blueprints, the prototypes, and the people who knew how to make them work. The goal was blunt: empty Germany of weapon knowledge before Germany could use it again or hide it. Keep those drawings out of the hands of any rival. Use what could be used to end the war faster and to save lives. Destroy the most dangerous stockpiles before a cornered enemy could do something reckless. Planning began months before the border crossings. Staff at Supreme Headquarters listed target industries and labs. American officers sat with engineers from the services and with government scientists to map what mattered. They studied how weapons were born. They looked for the beginning of a rocket, not only the finished rocket. They traced signals backward. A guided bomb needed a radio brain. The radio brain needed a firm that made special valves. That firm needed a supplier who made glass to a tight tolerance. The list grew. It included aircraft plants for jets, underground assembly lines for rockets, artillery design bureaus, explosives factories, optics works, steel mills that could pour the right alloy oil hydrogenation plants, cable mills, radar labs, and chemical works that had built a new breed of nerve gas in quiet rooms. Names were put next to each target. Some names were known, others were guessed. On the ground, those targets would be taken by teams that carried maps, cameras, empty satchels, and code words. They were small, fast, and trained to make choices in minutes. They would claim and hold while regular units pushed past. They would bring in trucks and lift the guts out of an office or a lab before the next morning. The makeup of the unit was unusual. It was American in command and logistics, and it pulled in anyone who could help. Army ordnance officers, Air Force test pilots, engineers who knew how to read a production line at a glance, interpreters, even factory managers who had run plants back home in Detroit or Pittsburgh and could smell what was important the instant they walked in the door. Many had done long days on stateside shop floors before the war. They knew the feel of a tool room that did new work. They knew what a development drawing looked like compared to a service copy. They knew the smell of acid in a plating room, the hum of a dynamometer behind a door with warning signs, and the lies that a plant foreman would tell to keep attention away from a secret annex. The teams traveled light. They kept spare film, demolition charges for emergency denial of a dangerous stockpile, a short list of questions for managers, and the authority from the highest level to take what they wanted. The first deep test came in the autumn rains. As the United States 1st and 3rd Armies crossed into the Reich, the small technical teams followed. In Aachen and the towns just across the border, drawings were found that hinted at a network of projects that reached far to the east and south. The names of aircraft like the Me-262 and R-234 were not secrets by that point, but the data on fuel lines, on compressor blades, on heat-resistant alloys, on turbine tolerances, that was the gold. The teams learned something fast. Blueprints were never all in one place. A jet engine was on paper sets, spread over 4 towns. Part of the compressor was at an engine firm, part at a machine tool builder. The special bearings were from another plant. The alloys were spec'd by a research office in a different district. That meant speed mattered. If the unit was slow, trucks from Berlin or Munich would arrive first, and the shelves would be swept clean. If the unit was fast, if it put a guard on the street and a clerk at every door, The drawings could be boxed and on a truck before anyone else knew the Americans were in the courtyard. As the Battle of the Bulge began, the small unit had to fight time as much as the German army. The lists were refined at night. Priorities were set. If the front bent, the order of targets shifted. The teams worked with Corps G2 sections to get route clearance and to know where they could move without being cut off. They learned to fish in the same muddy water where other secret fishermen worked. German officers tried to move files to the Alps. Party officials tried to burn records. Allied rivals wanted the same prizes. The unit turned to rail yards to watch for unmarked wagons, and learned the trick of looking for guards who were not wearing factory caps. A guarded car in a quiet siding after midnight told its own story. If the unit reached it, they broke seals and pulled bundles of drawings tied in twine off the floor. Those bundles went to the back of an army truck under a tarp and were driven away before dawn. The work took a sharp turn in December when the hunt for rocket secrets entered a new phase. Bombers had smashed Peenemünde earlier, but the design work did not end there. The Germans had scattered the V-weapon program. The underground tunnels at Nordhausen and the nearby Dora camp were taking that scattered work and making rockets in the dark. The unit followed the paper and the rumors south toward the Harz Mountains. When the area was finally taken, the sight inside that tunnels was a shock even to hardened men. Rows of rockets, test stands, gauges, crates of parts, and paperwork lay in damp caverns. The men worked in cold air by lamplight, tying tags to clusters of documents, taking photographs for catalog numbers, and moving selected sets to trucks. They knew they were not only seizing weapons, they were seizing a method. Every test log helped the United States skip a failure that the Germans had already made. That meant faster progress on American projects, and it meant fewer accidents down the road. It meant fewer pilots dead because a compressor blade cracked or a fuel valve stuck. In a war defined by numbers as much as by courage, the ability to skip a mistake was a form of mercy. At the same time, other teams went after the Luftwaffe's crown jewels. Jet and rocket aircraft were not just fast, they were a new set of problems. An aircraft that flew on a turbine needed a different maintenance doctrine, a different fuel supply, and a different runway. The team that focused on aircraft brought test pilots who could sit in a cockpit, read a German checklist, and know if the airplane could be flown away. They did not just take planes, they took shop manuals, flow charts, quality control sheets, heat treatment schedules, jig layouts, and tool lists. They took the engineers too, when they could. Inside hangars at Lechfeld and other airfields, men in leather jackets compared blade counts and asked about the life of a turbine disc. They searched tool cribs for odd-shaped gauges and for ring gauges stamped with codes that matched the drawings they had found in a back office. When pilots ferried me 262s to the coast to ship them to the United States, those planes were accompanied by pallets of documents that told how to keep them running. Without those papers, any jet was a dead bird after a few hours of flying. With them, each captured plane was a teacher. The radar and radio teams were the quietest of all. They had the most to gain from speed and the most to lose if they missed something small. Radar works by very particular pieces. A small cavity magnetron without a serial number could be worth a bomber wing if it filled a gap in an American lab's knowledge. The Americans gathered sets and spare parts from tracking sites and from factories that made tubes and coils. They rolled up Freya and Würzburg equipment, signal processors, airborne radars, and the notebooks of the men who tuned them. They took the black books that listed frequencies. They took the forms that listed what an operator did on a foggy night. The value was not only in a box of electronics, the value was in the way an enemy used it, how often it failed, and how they trained to overcome those failures. Those pages cut time from American training and design cycles. Every hour cut from a design cycle in wartime saved lives, because it meant a better countermeasure reached the front sooner. A bomber could carry a jammer that worked, A ship could find a periscope in a wave pattern before a torpedo broke free. The chemical teams moved with a different kind of urgency. They had watched reports of new chemical agents from field labs since 1943. Now they were closing in on the factories that had scaled those agents from grams to tons. They carried lists of plants that made advanced nerve agents and the intermediates that formed them. When they walked into a plant office, they asked for process flow diagrams. When they walked into a warehouse, they looked for drums with special coatings. They took formula books, reactor drawings, catalyst logs, and quality control charts. They took maintenance manuals for glass-lined reactors, and they took the specifications for protective gear. Where possible, they forced managers to show them the waste pits and the neutralization gear. The reason was simple. They could not allow stockpiles of nerve agents to be moved to the last redoubts. They could not allow panicked officers to think that a terrible splash of chemistry would change the course of the front. By taking the means to make more, and by taking the record of what had been made, they could count what dangers still existed, and they could plan how to render them harmless. In a few cases they set shaped charges on valves, because there was no time to do anything else before a retreating column came up the road. When possible, they moved full document rooms into USA Control, then brought in chemical service units to drain tanks and destroy precursors. The claim that lives were saved here is not abstract. A drum that was emptied and neutralized in February did not become a cloud in April. Steel and fuel were the skeleton of the German war machine. The unit understood that. It moved into steelworks and asked for heat treat books and for files on alloying elements that made gun barrels last longer or tank armor less brittle at low temperatures. Those pages gave American designers hints for better performance under fire. At synthetic fuel plants, the unit studied how Germany kept tanks and planes moving after crude oil supplies fell. They gathered the texts on hydrogenation, the layout of compressors and reactors, and the failure logs from when bearings seized and killed a train of machinery. These books were not sensational, but they were keys to understanding the enemy's endurance and the points where it could be broken again if needed. They also told where to look for spare parts that might still be hidden in a nearby depot. If a compressor used a unique seal, then a small warehouse down the road might have a few left. If those seals were taken or destroyed, the plant could never start again under any new flag. As winter turned to early spring, the unit learned to expect a final frantic effort by plant managers to hide what mattered. Drawings left the main office and were pushed into the countryside. Engineers stuffed pages into barrels and buried them behind barns. The unit answered with speed and a certain kind of mercy. They interviewed clerks first. Clerks know where paper sleeps. They offered a pencil, a cigarette, and a promise that the sooner they found the seller, the sooner everyone could go home. In many cases that worked. A nervous hand pointed to a wall. A hollow knock revealed a false panel. Behind it were rolls of blue paper tied with string and stamped with codes. Those rolls went into a canvas bag. The clerk wrote receipts for the Americans so they could check against inventories later. This quiet, simple work pulled the threads that tied a weapon to its plan and kept that plan safe from a last fire. In late March and early April, the tempo changed again. Because the Western armies were moving across Germany with growing speed, the unit's trucks kept pace. One day it might be a factory that made optical glass for gun sights. The next day it was a cellar with stacks of photographs from rocket tests. The next it was an aircraft engine shop, where crates of turbine blades were lined up with inspection slips. The men learned to read a shop floor as if it were a book. A box of scrapped parts told them a process was hard and still experimental. A line of packed crates told them a process was mature. The stories that paperwork told saved months back in the United States. When an American plant manager looked at a German inspection sheet that said one alloy lasted 70 hours before failure and another lasted 90, he did not have to ruin 2 months trying both. He could start a notch higher and put better engines on wings sooner, so a pilot lived to write a letter instead of a name on a plaque. The race into the Southwest brought the unit to university towns, where the air smelled of chalk and machine oil. In those towns, physics and engineering departments had built the research that fed the factories. In quiet halls, the walls still had chalk notes that a professor had not erased. A small reactor sat in a cellar with fuel cubes that were heavy in the hand. Next to it were notebooks that spoke of how long it had been run and what it needed to reach critical mass. The unit took the cubes, the notes, and the men who knew the answers. They quietly shipped them to American custody. At the same time, they removed a pressure on the battlefield. Those labs were not going to produce a sudden wonder, but they could have fed fears and triggered desperate acts. By taking the research people and their papers, the unit kept the end of the war from being a more frightened and dangerous time. The teams that focused on the Navy had their own race. German submarines were getting quieter and faster. A new type had long underwater range and better hull shapes. That kind of change could change war at sea. The unit entered shipyards and design offices and took the scale drawings of the hull, the plans for the snorkel, the designs of the new batteries, and the lists of equipment for the sonar and radio. They also took the training manuals that told how the new boats would fight. Those pages let the United States skip a long path of trial and error in its own post-war designs. More important in the moment, they let Allied escorts change their hunts before that new boat could appear in numbers. The faster the escort commanders got a sense of what they would face, the more likely they were to win the next fight and bring a convoy home. Saving one convoy in 1945 saved ships and crews that would feed the drive into the Pacific. It added weight to a strategy that ended the next war sooner. In factories where small arms were made, the unit did not spend much time admiring weapons on a rack. They went to the tool room where gauges were kept, a gauge shaped like a letter C that matched a part number on a carbine drawing, told them what tolerance the Germans held. They opened cabinets and pulled out process sheets that showed what speeds and feeds machinists used on hard steel. They took heat treat recipes that said how a gun barrel had to be tempered so it would not crack in winter fighting. They took the production balance sheets that revealed what slowed a line. Those sheets let American factories learn. They learned how to make a stamp-hardened receiver faster. They learned how to cut a feed ramp with a cheaper cutter. Those small changes let the Army get more weapons for the same money and time. That meant more rifles reached more soldiers in any future fight. In 1945, it meant that the United States had more choices about what to build and ship, which made command plans stronger and made the end come sooner. The unit never worked alone in practice. It sat inside a web of other arms. Combat engineers blew doors for them when a manager stalled too long. Military police set perimeters. Signal units put a guard on a telephone switchboard, so a clerk could not make a call that would empty a warehouse. Field hospitals stood ready to treat a worker who got hurt pulling a crate down a staircase. Logistics officers found the trucks and rail cars to move loads. That quiet support is one reason the unit worked. Another was the authority behind a plain piece of paper. It told any American officer who asked that the bearer had the right to take whatever he needed for the war effort. That paper ended the few arguments that did not end with a cigarette and a chair. There were hard choices. In a few places the unit could not move everything. They had to choose what to save. They picked what would teach the most. A single set of process sheets might teach more than a dozen crated models. A set of training films might be more useful than a rack of finished parts. In a chemical plant, the destruction of a pump train might make more sense than risky transport of unstable drums. The men slept on those choices and carried them into the next morning. They were not knights with shining armor. They were men with clipboards and intuition who tried to read the war through the steel and paper in front of them. Their measure was not only what they got out, it was also what they kept from getting loose. The human side was constant. Managers lied to save their jobs or their necks. Workers hid their notebooks because they did not trust anyone in a uniform. Some engineers wanted to talk because they were proud of their work. Some wanted to talk because they wanted to get out of the country as soon as possible. The unit learned to listen and to test. If a man said he had designed a rocket pump, he had to draw the pump on a chalkboard and answer 20 questions about cavitation, seals, and failure modes. If he could not, he went to the side, and a different man came in. The team learned that smart people did not always keep the best records. That is why they took everything and sorted it later. A stained notebook sometimes held 3 pages that were worth a year of effort in a lab. Those 3 pages got an index number just like a thick binder did. Back in the States, analysts would file, translate, and copy. What mattered in the field was to put the paper in a crate and the crate on a truck. As April turned to May, the unit pushed into southern Germany, into factory towns at the foot of the Alps, and into mountain retreats where party men had tried to hide intelligence. The unit found caches in barns, in churches, in salt mines, in caves where the temperature never changed. They brought lanterns and rope. They climbed and pried crates open. They worked off a master list that had been growing for a year. When a crate held a camera with special lenses and a list of units that used it, it mattered because those names led to more crates. When a cave held nothing but blankets and canned food, they marked it and moved on. The rush was ending, but it did not feel like it. They knew that surrender on paper did not end the risk, that a frightened man with access to a tank of chemicals might do something stupid. So in the last days they moved faster, not slower. They put guards on doors and gates, and they kept their questions short. Where are your drawings? Where are your test logs? Where are your storage tanks? Where are your engineers? The answers came faster because war weariness had finally broken the last resistance in many towns. Men and women were tired. They wanted to see the end. By the time silence fell on the Western Front, the unit had done what it set out to do. It had pulled a country's weapon knowledge up by the roots. It had taken the origin papers, the design sheets, the trial records, the test film, the gauges, the training texts, and the minds that held the rest. It put them onto ships and trains. It filled vaults and lab shelves in the United States with a decade of research that had been paid for by an enemy. It took factories off the map by making sure no one could ever run them again in the same way. It kept poison from spreading in the final weeks. It kept rumors from turning into rockets, and rockets from turning into last-minute strikes that kill for nothing. How did that save lives? It saved lives in Europe when it took nerve agents off the table. It saved lives on the sea when it gave escorts a look at what they would face next and how to beat it. It saved lives in the air when it let American pilots and engineers skip dangerous trial steps and keep their wings and engines together. It saved time for commanders who needed to know if an enemy had one more trick left. By answering that question fast, the unit let generals make choices that shortened fights instead of lengthening them. It saved lives quietly in the years after by giving the United States a store of knowledge that made future wars shorter, because the learning curve had already been climbed at someone else's expense. There was another effect that is hard to put into numbers. The unit took fear out of the last month. Fear is a killer late in wars. It makes leaders do wild things. It makes civilians panic. When the men with the SU clipboards walked into a plant, took the files, drained the tank, and drove away, they took the black unknown and turned it into a gray known. They could tell their own side, in calm words, what existed and what did not. That kind of certainty is a relief. It kept some bombers from flying. It kept some towns from being shelled. It kept some orders from being written in a fever. The work had a cost. Men hauled crates upstairs for days without sleep, and strained backs that would trouble them for years. They breathed dust in tunnels and chemicals in labs, because the job could not wait. They made hard calls about what to destroy when there was no time to move it. They were not famous and they did not write many notes about what they did. The little notes they did write sat in file drawers, but what they lifted out of basements and factories touched everything that came next. It showed up in training manuals, in design standards, in procurement lists, and in the choice of which research programs to fund and which to leave behind. There is a final scene that tells the whole story. A small group of men stand in a machine hall with high windows. It is quiet, and the air is cold. On the floor is a marked path where a trolley once ran. On the benches are jigs that held thin steel while it was drilled and cut. In a back room, a clerk is opening a safe with shaking hands. Inside the safe are folders with copper clips at the top. The men put those folders in a canvas bag, and one of them signs a piece of paper with a blunt pencil. A truck is idling outside. In 10 minutes the hall will be empty. In a week that folder will be in a new safe an ocean away. The machine hall will stand empty and then it will be turned to something else, or it will be pulled down. The war moves on. The folder stays important. It is read by someone who knows exactly why it matters and what to do next. Somewhere down the line, a pilot lands a plane that would have broken apart without a change someone made because of a line in that folder. Somewhere else, a ship finds a shadow in the waves because of a box that exists because of a drawing in that folder. The war is a chain of causes like that. The quiet hunt for blueprints and brains cut links out of the chain that would have led to more funerals. In the long view, the unit showed a truth that people in uniform and in labs have always known. Wars do not end only on battlefields. They end in file rooms, in factories, in training schools, and in the minds of engineers. When you take the papers and the teachers away, when you take the ability to make a thing as well as the thing itself, you end a war faster and you keep it from starting again the same way. That is what the men with the lists and the canvas bags did in those months. They took away the enemy's future and gave their own side enough knowledge to survive the present. They did it fast, they did it quietly, and they did it with a clear eye for what would save lives now and in the years to come.